Hello and good morning, CTS265 Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this morning's video tutorial is going to be a video tutorial on Cisco Learning Labs Discovery Activity number 10, where we're now going to start to take a little deeper dive look at OSPF, and specifically in this activity, we're going to be taking a look at the Link State Database. And so you can maybe think of this as sort of analogous to the topology table in EIGRP, although there are some differences, but the Link State Database needs to be the same on all routers in the same area. And we'll talk about router 1 here, the area border router, who is going to have to maintain a copy of the entire Link State Database for Area 0, Area 1, and Area 2. Because router 1 is an area border router. We've got router 3 here. You can see we've got an external source of information. This could be BGP, it could be EIGRP, could be any other external routing protocol that is not part of the OSPF autonomous system that we have set up here, right? And so that's why this is called an autonomous system boundary router. You'll also hear it referred to as an autonomous system border router in some cases, but again, they're both the same terms, both synonymous. Okay, so we have router 4 here, so let's jump onto router 4 and let's go from user exec into privilege exec in the global config, and we're going to say do show IP route OSPF. And so here's what we're looking at right now. You can see we've got some different OSPF routing information, and we also have some new information that we haven't yet seen before, and that's going to be this E2, right, or the OE2. And if we come up here to our chart, we can see that when we're talking about E2, it's an external type 2. Now this is the default for external information. When a type 5 LSA, and we'll talk about the LSA types, but it's a type 5 external autonomous system LSA that is generated by the ASBR, right? So it's going to be generated by that autonomous system boundary router, and it's going to be flooded into all areas. And except for, and there's some caveats there as to whether or not it goes into some of the special areas like totally stub, not so stubby area, and we'll talk about those as we get to them. But for right now, we're going to keep in mind that the ASBR will flood a type 5 LSA, and it'll go into all of the different areas. In our scenario here, obviously, again, there's some special cases, but we'll get to those. So we've got our type 5 OE2, and we have some inter area. So we have these two inner area prefixes here, the 2/30s. And then we have an intra area, not inter, intra. So this is actually 192.168.1.0 via router 1. So this is in our area, the area that we sit in. Router 4 again is in area 0. And then we have some more external, excuse me, or I should say inter area, so coming from a different area. Some routing information there. Now let's take a look at the database. And so this is going to be, this is how you see the Link State Database, where you say do show, whoops, sorry, where you're going to say do show IP OSPF database. And this is the Link State Database. Now, what you'll notice here is that it's going to list out the information sort of in LSA order. And what I mean by that is we have at the very top, we have our router link states for, and it tells us there, for area 0. So this is an LSA type 1, or a type 1 LSA. And that's the router LSA. Now, excuse me. Now this is generated by, the type 1 is generated by every router in an area, but it's local to the area. So in other words, the router 4 type 1 LSA is not going to show up over in area 1 or area 2. And that's when we're going to get to the summary LSA, the type 3. We'll talk about that. So type 1 LSAs are router LSAs. They're generated in every area. And one of the important fields here is this link state ID. And you'll notice we get different values as we go down here. So the link state ID, when we're talking about the type 1 LSA, this is the router ID. ID. So let's get that in there. This is the router ID here for these entries. So the router ID for router 1 and the router ID for router 4. So those are the only two that we see, and this should prove to us that we're not seeing router 3 and router 2 in here, right? We don't see a type 1 for them because they're in a different area. So this proves that this is local to the area. Now we get down to the net link states, right, or the type 2 LSA, the network LSA. So this is type 2, and again, these show up sort of in LSA order, and so here's your summaries. This is going to be type 3, right? So here's our type 3, and then my favorite, the type 4, sort of the albatross of LSAs. So type 1, type 2, type 3, then we see type 4, and our type 5 LSA, which is that autonomous system external LSA, right? And we're still talking about area 0 here, so type 5. So let's go ahead and continue with our type 3s. When we look at those type 3s, I'm sorry, we've got to go back to the type 2s. When we look at the type 2s, you can see we only have a single entry here. Now the DR, right, the designated router is what is generating the type 2 LSAs. So you can see the advertising router is 4.4.4.4. Well, then that begs the question, the link state ID. Now remember, here it's the router ID. You can clearly see that here it is not the router ID because we're not seeing 1.1.1.1 or 4.4.4.4. And the type 2, just like the type 1, it has area scope, right? It's area scope, which means that type 1 and type 2 are only seen in the area that they are going to be generated in. If they're, well, type 1 is always generated, but the type 2 may not always be generated because again, it's generated by the DR. And what that means is if there's no DR BDR election, so if we're talking about point to point, or if we're talking about point to multi-point, I'll just say point to multi-point, right? If we're talking about point to point, if we're talking about point to multi-point, basically any other option other than broadcast or non-broadcast, and there's no DR BDR election, you will not see a type 2. You will not see a net link state LSA generated. Because again, those other types, they're assuming that there's no need for the DR, right? Because there are a limited number of routers that will be on the links. Okay, and in a point-to-point case, it's going to be 2. So there's really no need for a DR or a BDR. All right, so then we get the link state ID, right? This ID column here, and this is the IP interface, right? So that's the IP address of the DR, and that's what that link state ID is. IP address of our DR. And so 172.16.4.2, my guess is that could be router 4, right? Because you got advertising router is right there, and that is the interface IP for the DR. Now we come to the summary network link states. Now, one thing that tends to confuse learners is they see this and they see that term right there, which we've been driving home with all of the routing protocol usage. You see it throughout your CCNA studies, and so you think summary networks. Okay, well these must be IP summarizations of these networks, when in fact that is not the case. And so this is where it could be a little confusing when you see that summary network link state. So what the summary network link state is all about, this is our type 3 LSA. And what it is it's an LSA that's generated by an area border router, the ABR. And we know router 1 is our ABR, and in fact you can confirm that right there because we can see that router 1 is generating 3 different type 3 LSAs. And so the 3 type 3 LSAs represent information, summary information about the other areas, not about the IP addresses, right? So it's not IP address summarization. These type 3 LSAs are LSAs that provide a summarization of the other in this case, non-zero areas. So in the other non-zero areas, right? So area, I believe it was 1 and 2 possibly. So that's why we're getting this information. And so the question is, this link state ID field right here, this is simply the destination network. So here is, in the type 3, there is no better case. And let me just put in here destination network. So if I was trying to get to the 192.168.2.0, I need to recurse and I need to get to router 1 with the router ID 1.1.1.1. So these are networks that are not in area 0. And in order for me to get to those networks, I need to get to 1.1.1.1. Well, do I have a link to 1.1.1.1? Yeah, here's the router LSA right there. I know exactly how to get there, right? So this is a destination network here. And I'll just put destination net, and it's non-area 0, right? Because that's the area that we're looking at right now from the point of view of router 4 here. And so that's the type 3 LSA. I get summary information from the area border router that basically says, if we were saying it in plain English, the ABR would be saying, hey, everybody in area 0, I know how to get to these networks, these 3 networks right here. If you need to get to these 3 networks, you just simply need to be able to get to me, and then I'll take care of everything else for you. Now, you may be asking yourself, well, wait a second, Travis, you said that the link state database needs to be identical on all routers. And again, let's complete that sentence. It's all routers within the same area. And so this is the distance vector behavior, is the type 3 LSA is distance vector behavior, just like EIGRP, right? Because area 1 and area 2 have provided this information to the ABR, the area border router, and the area border router is not sending in the entire link state database to all other routers. It's simply sending in a summary. And it's basically the type 3 LSA is that summary. And the summary just basically says, hey, here's some networks. If you need to get to them, come to me. And remember, EIGRP, it's the same thing. It's routing by rumor. You're trusting your neighbor. You only know how to get to what your neighbor is telling you about, right? You only know how to get to the networks that your neighbor is telling you about. And so that is that distance vector behavior. All right, so let's go ahead now. We're going to move on to my favorite LSA, which is the type 4 LSA. Now, the type 4 LSA is the summary autonomous system boundary link state. And so what is that all about? What would the summary autonomous system link state be all about? Well, if you're thinking that it's got something to do with possibly a type 5, then you could very well be right. So the type 4 LSA is very similar, and I want to say similar kind of in function to the type 3. Whereas with the type 3, we've got these networks here, a summarization of these networks, where router 1, the advertising router, is saying, hey, if you need to get to these networks, come to me. And the ASBR is much, I should say the summary ASB, right, or the autonomous system boundary link state is very similar, because what it does is it tells everybody how to get to the autonomous system boundary router, right? How to get to the ASR, and that is what that link state is all, or that's what this LSA is all about. And so when we look at the type 4 LSA, you can see that we have the link ID and then the advertising router again. So again, it's sort of this link state behavior with router 1 flooding into area 0, that update right there that says, hey, if you need to get to 3.3.3.3, come to me. And I guess I shouldn't say to get to 3.3.3.3, excuse me, because this is, again, the router ID for the advertising router, right? It's the router ID for the advertising router. So we've got a type 4, and the type 4 basically tells you how to get to the ASBR so that you can get to this type 5 information. And so I actually kind of stopped a little too soon here. If I was to actually run that again, there we go, good. So you can see here that the advertising route, so it's sort of like a recursive process. Here is the network that's being advertised, is at 10.0.0.0, and it's coming in off of router 3. And router 3 is the advertising router. So the autonomous system, or I say the autonomous system boundary router. So the autonomous system boundary router sends in a type 5 LSA with the information, but then there's also a type 4 summary of that same information. And what we have happening here is routers that need to get to the 10.0.0.0 look at that type 5 LSA and say, oh, I need to get to 3.3.3.3, the router with the router ID 3.3.3.3. So then they do a recursive lookup and say, well, how do I get there? Because all they have is the router ID. They know the destination network, but all they have is the router ID. Well, they recursively look up the router ID in their link state database that says to get to the 3.3.3, because that is the router ID, all I need to do is be able to get to 1.1.1.1. And do I have an entry for 1.1.1.1, a type 1 LSA? I certainly do. And that's exactly how the type 5, type 4, and ultimately the type 1 work. Is that, excuse me, they're just simply recursing along the path, trying to get to a router that can get them over to the autonomous system boundary router. And so that's the recursive process that takes place with that link state database. All right, let's clear the screen. Let's move on with our activity here. So we took a look at the database. We discussed everything that's in there. You can see a specific LSA. If I were to say do show IP OSPF database, and if I do a question mark, you can see we can take a look at an advertising router link state, an ASBR summary. There's your type 4. We can see a database summary, the external, your type 5. We've got a network, the type 2, right? So the NSA external, that's when we're starting to talk about type 7 LSAs. The opaques are 10 and 11. Excuse me, the router is our link state 1. And you can see down here, summary is the 3. So if I were to just wanted to see one specific LSA, right, here are the router LSAs, and we get a bunch of additional information in here specific just to the router LSA, and this is the information included, right? This is the information included with your LSAs. You see the link state ID, who the advertising router is. We get our sequence number, and you also see something very important. So that type 1 LSA that router 4 is receiving, you can see right here the router with the ID 4444, about router 1 tells it that router 1 is an area border router, right? And so we know from looking at this that router 1 is an ABR. All right, so now let's go ahead. We're going to transition down here to step number 4, and you can see the locally generated, right? So what did we see here? We see the remote generated type 1 LSA, and by remote I mean this is router 1's LSA, type 1 LSA information that we were just looking at. If I specifically wanted to see, whoops, sorry, the self-originate, so here is the type 1 LSA that router 4 is generating. Now you'll notice, does it say area border router here? It does not, because again, router 4 is not an area border router. And so this is the LSA that's type 1 LSA that's being generated by router 4. All right, excuse me. Now we're going to jump over to router 2 over here in area 1. Now remember, this is multi-area OSPF. So a type 3 LSA is going to be sent into area 1 from router 1, because router 1 is the area border router. It's connected, and again, remember that definition of the area border router is any router that has one or more interfaces in area 0 and at least one interface in another non-area 0 area. All right, so now we're going to take a look at router 2, and we want to see the database from the perspective of a router that's over here in a different area. In fact, is it area 1 or 2? It's area 1. So router 2 is in area 1, so we're going to say show IP OSPF database, see what the link state database looks like. And we can see that right now router 2 is showing simply that single link ID, and I don't believe that is correct. It should be seeing far more than that, which is leading me to wonder, let's do this, if there might be something wrong with router 2 here in the sim. Excuse me. So while router 2 is rebooting, because it should be seeing way more than that, we'll come back over here to router 1 and get into privilege exec and say show IP OSPF database. There we go. And that's what we're looking for. So we can see far more information here, but you can see that since it's the area border router, router 1 is getting information and must maintain a full link state database for area 1 as well as area 2. And remember that the type 1 and the type 2 LSAs, those are bound, those are local area scope, right? So type 1 and type 2 LSAs are not flooded into other areas. So you'll have type 1s in every area. You'll have type 2s in areas where you've got a multi-access segment, or I should say a DR, BDR election is going to take place. And a DR exists, but that in those areas, those LSAs are not sent over to other areas. All right, so let's go over to router 4 right now and take a look at a type 2 LSA, a network LSA, and see what that looks like. So we say show IP OSPF database, and which one would we use? Exactly, network. And there's your network LSA. It shows us the CIDR notation here of the network mask. Shows us the routers that are attached. Remember, this is being generated by the DR. So we're on router 4. If I was to say show IP protocols, we can see, where are we at here? Show IP protocols. You can see that we are routing for those networks in area 0. We've got some gateway information, and this was not the command I was thinking of. I'm thinking of show IP OSPF. Hold on one second. And the command is completely not neighbor. I don't believe it's neighbor. Yeah, so it shows router 1 is the BDR. Show IP OSPF interface. Sorry, show IP OSPF interface. There we go. I totally had forgotten about that for a second. And you can see the designated router ID. We can see that router 4 is, in fact, the designated router. So router 4 in area 0 is going to be responsible for making sure that that information gets propagated. So when we talk about the type 3 LSAs, if I were to say show IP OSPF database, and we look at those summary network link states, again, you'll hear, so it's kind of confusing when you hear the statement that summarization is not on by default and we're dealing with summary network LSAs. And so I want to make sure I address that because that's in the text as well as in the lab and can lead to some confusion. So this is our type 3 LSA. It's a type 3 LSA. It's a summary LSA. But like I said earlier, this does not mean summarization of IP addresses. So it's not like we're taking different networks like 10.1.1.0 and .2.0 and .3.0 and summarizing these guys. That's not what we're doing. That's not what this summary LSA is about. So from the OSPF perspective, what we are summarizing is the area, the information from another area. And then that information is passed through the ABR, the area border router, who regenerates the information that he's learning from that other non-zero area and sends it into area 0, in our case here. Again, he's going to send the same information into area 1 or area 2, depending on which information he's learning. So area 2's information goes to area 0, area 1. Area 1's information would be summarized as a type 3 LSA into area 2 or area 0. So we're in area 0 here, and so this is what we see. Now, the statement summarization is not on by default. What that means, it doesn't mean that type 3 LSAs, that the summary net link state LSAs are not on by default. This is OSPF, and that is going to happen if OSPF is running. And we've got multiple areas. We are going to get type 3 LSAs, and the summary net link states, these are on by default. The statement that summarization is not on by default is that there is no summarization of the routing information in the type 3 LSA. So what do we mean by that? Take a look at these two link IDs. And again, remember the link ID for the type 3 LSA is the network number that's being shared or regenerated by the ABR and sent into these other areas. And it shows these two networks. So when we say summarization is not on by default, what we mean is 172.16.12.0 and 172.16.13.0. Whoops, I did not mean to do that. I apologize. In fact, I'm not even sure how it did that when in drawing mode. So let's drag this back over. Oh, it actually shrunk it. Okay, I see what happened there. So let's, there we go, a little better. All right, so what it means is there's no summary IP address summarization that takes place. And you can see that that is the fact, right? That there is no summarization of these two networks, which we could do a summary for. We're seeing each individual network. And so, again, just to be clear, the summarization of IP addresses is not on by default in OSPF. But the type 3 LSAs, these are on by default. These are critical, right? These are critical for OSPF. So again, I definitely want to clarify that because that does tend to cause confusion when learners see that statement, summarization's not on by default, and then they immediately say, well, wait a minute, I'm seeing type 3 LSAs. If it's not on by default, how did it get turned on? But, excuse me, that is not the summarization that we're talking about. All right. So now let's go ahead. We can take in. You can even take a closer look for any of the LSA types. You can go deep dive. See, I get a lot of information here. If I only wanted to see the summary information, I could say show IP OSPF database summary, and now I'm only getting the information on the summaries. And remember this as well, routing bit set, right? This comes into play a little later on in the course. But remember, when the routing bit is set on this LSA, that means that it is being used, right? That we can actually actively use this for the routing of information. And again, here are the link state IDs. It's the summary network number, but it's not that the network has been summarized in terms of IP, right? It's a summary network number for this type 3 summary LSA. So again, definitely can be a little tricky there with just the terminology. All right, so now we're going to go on to router 4, and we're going to take a look at the summary ASBR. And so again, that would just simply be rerunning this command and saying, whoops, ASBR summary. Now remember, the ASBR summary, the Autonomous System Boundary Router summary, is the information that we need to be able to recurse to the ASBR. It's to that OSPF router that has an interface that's running OSPF and is in an OSPF area, as well as an interface that's receiving external routing information. And so again, you can see that it gives us that information here. And then finally, we'll take a look at the Type 5 LSA. And remember, the Type 5 LSA is flooded into all areas. In our scenario, again, there are certain special OSPF areas where that doesn't take place, but with what we're dealing with here in this context, that Type 5 LSA is going to get flooded to all areas. So when I said show IP OSPF database, you can see there is the Type 5 LSA. And router 4 is in area 0. So this Type 5 LSA came in from router 3 to router 1 and then into area 0. So from area 2 into area 0. Did it make it over to area 1? So if we come over here to area 1 and we've just reloaded here, show IP OSPF database, let's see. Yeah, there we go. All right. Looks like router 2 was just hung up. And absolutely, that Type 5 LSA, again, it's advertising, hey, I've got external information, external routing information that's not coming from our OSPF domain. And here's how you get to it. You go to the advertising router 3.3.3.3. Well, router 2, right? Router 2 up over here, does he know how to get to 3.3.3.3? Because it's in a different area. And the answer is that he does, because he wants to get to that external information here, that 10 network down here. He needs to get to the 3.3.3.3. How is that possible for router 2? Well, it's very simple. He looks at the summary. He looks at the Type 4 summary ASB link state. And he says, I need to get to 3.3.3.3. There is the link ID information, which tells me, hey, go to 1.1.1.1. It's like following street signs, right? How do I get to the 3? Oh, that's right. Here's the link ID. Get over here to router 1. And there we go. We have a Type 1 LSA for router 1, which means it's in our area. So I just recurse over to router 1. That is where I'm going to end up forwarding the traffic. And then router 1 will ensure that that information gets sent down to the proper ASBR. And that's what the Type 4 LSA is all about. It's sort of like a little helper. Helps you get to the ASBR so that you can get to this external routing information. Because if I say show IP route, and we're looking at that 10 network, there it is as an OE2. And you can see, what is the next hop address? 12.1. That is router 1. Because again, the link state database provides the router with the information needed to get to that next hop. Okay, and that was our Type 5 LSA. And we can again, you can again trim down the Type 5 LSA. So you could say show IP route, show IP route, show IP OSPF database, and external. And there is that Type 5 LSA. You can see we see the network mask is a /16. The metric type, and we'll talk about this as we move on, as a Type 2. We can change that and make it a Type 1, but right now it's a Type 2. The metric is 20, and that's the default metric for external information. No, the forwarding address is quad zeros, and the tag is all zeros. There's the advertising router. Here's the external network number. That's the network that we're trying to get to. So again, you can really drill down into this information and see quite a bit of detail in terms of what exactly does that LSA contain. All right, well, this is going to wrap up discovery activity number 10, where we took a look at the link state database. The next discovery activity is going to be discovery activity number 11, and that is going to be on the OSPF path selection, where we're going to start to take a look at the metric that OSPF is going to use, and we'll talk about the way we can manipulate that and perform layer 3 traffic engineering. All right, thanks for watching. I'll see you guys tonight.